Hi everyone, welcome to my channel. In this video, I will show you how to migrate applications and database instances from corporate data center to AWS Cloud using AWS Application Migration Services and AWS Database Migration Services. Before we dive into the demo, let me quickly introduce about myself. My name is Srinivasan and I have over 20 years of IT industry experience. And I'm also an AWS community builder since 2021. And these are the AWS certifications that I have achieved in the past. And I'm also an ex-AWS partner AIML Black Belt. And I'm also an ex-AWS partner ambassador. I think that's enough introduction about me. Let's now briefly see what AWS Application Migration Services is and its benefits and the use cases. And let's review the architecture that we are going to implement in this demo. First, let's see what AWS Application Migration Service is. AWS Application Migration Service simplifies, expedites, and reduces the cost of migrating and modernizing on-premises and cloud-based applications. Now let's see some of the benefits. Migrate applications from any source infrastructure that runs supported operating systems. Modernize your applications during migration with options such as disaster recovery and operating system or license conversion. Maintain normal business operations throughout the application replication process. Reduce costs by using one tool for a wide range of applications with no need to invest in application-specific skills. Now let's see some of the use cases. On-premises applications. Migrate applications such as SAP, Oracle, and SQL Server running on physical servers, VMware vSphere, Microsoft Hyper-V, and other on-premises infrastructure. Cloud-based applications. Migrate applications running on other public clouds to AWS. Gain access to over 200 services that lower costs, increase availability, and facilitate innovation. Between AWS regions. Migrate your Amazon EC2 workloads across AWS regions, availability zones, or accounts more easily to meet your business resilience and compliance needs. Application modernization. Optimize your applications by applying custom modernization actions or selecting built-in actions such as cross-region disaster recovery, Windows Server version upgrade, and Windows MySQL bring your own license, that is BYOL, to AWS license conversion. Now let's see the strategies for AWS Application Migration Services. A migration strategy is the approach used to migrate a workload into the AWS Cloud. First, rehost. This strategy is also known as lift and shift. Using this strategy, you move your applications from your source environment to the AWS Cloud without making any changes to the application. Next. Replatform. This strategy is also known as lift, tinker, and shift, or lift and reshape. Using this migration strategy, you move the application to the cloud and you introduce some level of optimization in order to operate the application efficiently, to reduce costs, or to take advantage of cloud capabilities. Repurpose. This strategy is also known as drop and shop. You replace your application with a different version or product. The new application should provide more business value than the existing on-premises application, including features such as accessibility from anywhere, no infrastructure to maintain, and pay-as-you-go pricing models. Next, refactor or re-architect. Using this strategy, you move an application to the cloud and modify its architecture by taking full advantage of cloud-native features to improve agility, performance, and scalability. This is driven by strong business demand to scale, accelerate product and feature releases, to reduce costs. In this demo, we will use AWS Application Migration Service to rehost, also known as lift and shift, a web application from the source environment to the target environment, leveraging the Amazon EC2 as the destination compute platform. So the first step is setting up of application migration service. To get started working with AWS Application Migration Service, the service must first be initialized in the AWS account. The initialization involves creation of IAM service linked roles and the replication server template. Replication servers are lightweight Amazon EC2 instances that are used to replicate data between your source servers and AWS, and their configuration is based on that template. Next step is installing agent on source machine. AWS Application Migration Service rehosts the servers to AWS by replicating block level data from the source to the cloud. This process can be agent based or agentless. For the sake of this video, we will rely on the agent based replication, which is the default recommendation for most use cases. The AWS replication agent performs an initial block level read of the content of any volume attached to the server and replicates it to the replication server. The agent then acts as an OS level read filter to capture writes and synchronizes any block level modifications to the AWS Application Migration Service replication server, ensuring near zero RPO. Next, update server details. We have to review and configure server details in this step. AWS Application Migration Service agent registers the source server and provides us information about the host and possibilities to customize how the replication will be executed. In this section, we will explore some of these options. Next, launching the test instance. This process involves launching a test instance, which is the terminology used by AWS Application Migration Service for rehosting our source application server to the target AWS environment. AWS Application Migration Service has a set of states that each source server would go through within the migration lifecycle. Those are like not ready, ready for testing, test in progress, ready for cutover, cutover in progress, cutover complete. So we will explore all these states when we do the demo. Next, launching the cutover instance. This process involves launching a cutover instance, which is the terminology used by the AWS Application Migration Service for the final EC2 instance after the rehost migration. Next, configuring the application. After launching the cutover instance, the AWS Application Migration Service has created the final EC2 instance in the target environment. This instance was created based on the data from our source server, which means that our workload is still configured to the source environment. Now it's time to update the application configuration to use the database from the target environment, which was previously migrated to AWS RDS database using AWS Database Migration Service. Next, finalize cutover. This finalization process will involve all AWS resources created by Application Migration Service for enabling the replication of these source servers will be terminated or deleted within 90 minutes. The AWS replication agent will receive a command to uninstall itself within 10 minutes. Launched test or cutover instance will not be terminated. Okay, now let's review the architecture that we are going to implement in this demo. So I have already created a simulated on-premises data center environment in US West 2 region. Now I have a web server on EC2 instance I have installed WordPress application on it. And I have MySQL server database on EC2 instance and configured the WordPress application to use MySQL database. I will show you how to access this web server application when we log into the AWS console. So this is the simulated environment that we have at the moment. So we are going to migrate this simulated web server and MySQL database on-prem instances to AWS Cloud. First, we will create a VPC on US East 1 region with 2 public subnets and 4 private subnets. First, we will migrate the MySQL server database to AWS Cloud using AWS Database Migration Service, and we will migrate it to Aurora RDS DB. Once the MySQL database is migrated to Aurora DB, we will use AWS Application Migration Service to migrate the web server, that is the WordPress application, to the AWS Cloud, that is to US East 1 region. Once we have migrated the application, WordPress application and the database to the cloud to US East 1 region, we will configure the application on US East 1 region, the web server that is on US East 1 region, to use the Aurora database. So this is the architecture that we are going to implement in this demo. I think that's enough theory. Now let's log into AWS console and I'll walk you through the process. Okay, I have now logged into AWS Management Console, and let me go to EC2 and change the region. Currently I am in US East 1 region. I'll change to US West 2 region, where I have configured the simulated on-prem environment. Go to instances, and you can see I have 2 instances, one on-prem web server where our WordPress application is running, and another instance is on-prem DB database instance where our MySQL server database instance is installed and configured. So now let me click on on-prem web server and copy the public IPv4 address, and let me go to the browser and let's access this one. So this is the WordPress application that's running on our web server instance. So I have just created this one sample blog here. So this is just quick introduction about me, and if you go to application migration with AWS hands-on learning, that's what we are implementing in this demo. So yeah, just a simple website. Let's go back to instances here. So these are the instances, as I said, like on-prem simulated on-prem server instances. Let's go back to console home. As we discussed, let's go ahead and create a VPC on US East 1 region. Let's go to VPCs. Currently I have one VPC, that's a default VPC. Let's create a new one and let's select VPC and more. Let's name it AWS VPC. And I can use this setter block, and I'm going to use this default tenancy and availability zone. I'm going to have it 2, and the public subnets, as per our architecture diagram, we need 2 public subnets and 4 private subnets. So when I clicked 4, it's increased here. And NAT gateway, I'm gonna have it in 1 AZ, but ideally we may want to have 1 per AZ, but this is a demo environment, so I'm just going to have it 1 AZ, and I don't need VPC endpoints for this one. And let me go ahead and create the VPC. So it's gonna take a while, and I'm gonna pause the video and come back once the VPC is created. I'm back now. Our VPC is created. Let's go ahead and view the VPC. And you can see that AWS VPC is created. And you can see the subnets. Yeah, it has 6 subnets and 2 public and 2 private subnets. So let's go ahead and create a security group here. Click on security group. Create a security group. We need to create 2 security group, one for the replication instance and for the database migration service, and one for the database that we are going to create, database in RDS. So let me name the security group as replication instance security group. Copy that and use it as the description. Select the VPC as the AWS VPC, and I'm going to leave the inbound rules as empty for now. And let's go ahead and create another security group. This is for our database, RDS database. So let me name it as DB. Let me name it as RDS database security group. I'm going to use the same as the description here. Select the VPC as AWS VPC, and I'm going to add a rule. I'm going to select MySQL Aurora for port 3306, and it's going to be custom rule, and I'm going to select the security group that I have created for our replication instance, because we need to have opened the 3306 port from our replication instance for the database migration to happen. So this looks good. Let me go ahead and create the security group. Okay, so we have created 2 security groups. Next, we need to create a database in RDS. I'm going to create a Aurora database. So in this section, we will perform a database migration with the AWS Database Migration Service. It's a managed migration and a replication service that helps move our database and analytics workloads to AWS quickly, securely, and with minimal downtime and 0 data loss. AWS Database Migration Service supports migration between 20 plus database and analytics engines, covering homogeneous migration, that is MySQL to MySQL, or heterogeneous migration like Oracle to Postgres, etc. So these are the use cases, and single or continuous replication mode supported. So let's go to console home here and go to Aurora and RDS, and make sure you are still in US East 1 region, North Virginia region. This is where we are going to migrate our application and database into. So first, let me create a subnet group. So this is the one that I created for my demo earlier. I'm going to delete this one. I don't need that here, and I'm going to create it new. Create DB subnet group. Okay. RDS DB subnet group. I'm going to use the same for the description, and I'm going to select the VPC, that is the AWS VPC that we have newly created, and the subnets. So for the availability zone, we have 2 availability zone, US East 1A and US East 1B from our architect diagram, if you remember. And subnets, I'm going to select the private subnets, private 3 and private 4. So because the public subnets, public 1 and public 2 is where our web server will be running, and we will have the private subnets for the future enhancement for application layer, and private 3 and private 4 subnet is what we have reserved for our database instances. So let me select AWS VPC subnet private 4 and AWS VPC subnet private 3. So these are the 2 private subnets where our DB instances will go into. That looks good. Okay, and let's go ahead and create it. It's created now. Okay, now let's go into databases. Let me clear this up. And I'm going to create a database. And I'm going to create Aurora MySQL compatible one. I'm not going to use a EC create. For templates, I'm going to use a dev or test. I don't need a production environment for this demo. And the DB cluster identifier, I'm going to leave it as database 1. Credentials, master username is admin. I'm going to use self-managed. I'm going to provide a password. Okay, confirm master password. Okay, looks good. And so I'm gonna use Aurora standard here. Instance configuration, I'm gonna use T classes, burstable instance, and T3 medium should be fine. And I'm gonna create a multi-ASA deployment as we described in our architecture diagram. And I'm going to leave it as not connecting to the compute resource at the moment. And VPC, I'm going to select our AWS VPC. And the DB subnet group, that's the RDS DB subnet group that we have created. And we are not going to have a public access for this DB instance. And security group, I'm going to choose the existing one. If you remember, we have already created a security group. That's RDS database security group. And I don't need this one anyway. I just need RDS DB security group that we have created, which allows port 3306 access from our RDS replication instance. And I'm gonna leave the rest. No, I need this. This is the same. I'm not going to change anything. Authentication. I'm going to leave that. Monitoring. It's going to be the standard one. I don't need an enhanced monitoring here for our demo. And so this looks good. I'm going to go ahead and create the database. So it's going to take some time. So I'm gonna. So while this is getting created, I'm gonna close this one. So while this is getting created, let's go to DMS service and create our replication instance as well. Here, let me go to console home. I'm in console home and select database migration service. If you don't see it like a recently used or visited as kind of section, you can always search for it here. Okay, you can see database migration service. Let me go into database migration service here and click on subnet groups. We need to create a subnet group where to tell that where we need to create our replication instance. So we need to create our replication instance in the public zone with a public IP address. So I'm going to name this one as replication subnet group. I'm going to name this one as the same. VPC, this is going to be our new VPC, AWS VPC. And subnets, it's going to be the public subnets. So let's select a public 1 and public 2 subnets. So both public subnets are selected and create the subnet group. Okay, so now we have created the subnet group for our replication instance. Let me go into replication instance here and create a replication instance. Let me name this one replication instance, and I'm gonna use the same for our description for simplicity. And instance, I'm gonna have leave it with the DMS-T3 medium. I think that's fine. I'm gonna leave this one as default. IPv4, that's fine. And VPC, I need AWS VPC. And this replication group, as replication subnet group is selected, the one that we have created with both public subnet, and it's going to be publicly accessible. And I don't think I'm gonna. Okay, security groups. If you remember, we have created a security group that is a replication instance security group. Okay, so I'm going to select the replication instance security group that I have already created, and everything else looks good. I'm going to go ahead and create the replication instance. So it's going to take some time for our Aurora database to be created and available, and also it will take some time for the replication instance to be created. Oh, okay. No, I have left the high availability for this demo. I'm going to use our dev or test workload. I don't want to create a replication instance in the multi-AZ for production workload, so I'm gonna select dev or test. Okay, that's why it's not created. So yeah, I selected that for the demo. So in a real world environment, you may want to create, in multi-AZ. Okay, yeah. Let's click on create a replication instance. Yeah, it's getting created. So it's going to take some time for the replication instance to be created and be in available state. So I'm going to pause the video and come back once the database is created and it is in available state, and also the replication instance is created. Okay, I'll be back soon. Okay, I'm back now. Our replication instance is created and it is in available state. It's created in available state, and let's go to our Aurora RDS. So our Aurora RDS also is created and it is in available state. So go back to DMS service and our replication instance. Let's copy our public IP address of the replication instance. And we need to go to the instances, that is On-Prem DB instance and US West 2 region, Oregon region, and click onto On-Prem DB instance and go to security and go to the security group, that is On-Prem DB security group. We need to edit the inbound rule and then add a rule for MySQL or Aurora connections. On port 3306, it's going to be a custom source, and we're going to give the IP address, that's the public IP address of the replication instance. We need to enable the port 3306 for our replication instance for the migration, database migration to happen. Now let's save the changes, and we need to configure our source database. To ensure minimal downtime for database migration, we are going to use continuous replication of changes, also known as change data capture, that is CDC, from the source database to the target database. For AWS DMS continuous replication with the MySQL database as a source, we need to adjust the configuration of the source database. For that, we will connect to the server through a virtual terminal and execute a few commands. So I have selected On-Prem DB instance, and I'm going to click on connect. I'm going to connect using EC2 instance connect. It is establishing connection. And so now we have connected to On-Prem DB instance. In the terminal, we need to connect to MySQL server and grant privileges for the database user, the user that we will use with a CDC feature. I have created a WP_user for this WordPress database that I have created. So let me connect to MySQL. Now let me grant the privileges. Okay, I have provided the privileges. Now let me exit. In MySQL, the binary log contains events that describe database changes such as table creation, operations, or changes to the table data. This is crucial for the continuous replication task with the DMS. In the same terminal, let's create the directory structure for MySQL binary logs. Connect to a super user. Create this directory structure and change the ownership. Good. Done. Then let's modify the MySQL configuration to enable the binary log. In the terminal, we need to execute the following commands again. So for that, we need to be super user. Let me clear the screen. Let's do the change ownership. Let's provide this. Okay. Let's see this file. Yeah, looks good. Everything is included. Okay. Let's clear the screen again. To have changes implemented, we need to restart MySQL service. So let's restart it. Okay, now after the restart, let's see in the terminal if the changes took effect by running these following commands. Let's see if the binary logging status is on. Good. And binary log format is row. That's good. Okay, I think that's good now. Now let's go ahead and create a source and target endpoints, and then create and run a replication task. So let's go back to database migration service here and go to endpoints. Let's create endpoints. First, let's create source endpoint. Source endpoint identifier, a label for the endpoint to help you identify. So we're going to use source endpoint, and the source engine is MySQL. I'm going to have the endpoint setting. That's fine. And I need to go. Provide access information manually. For the server name, let's go back to US West 2 region and on-prem DB instance. That's our DB instance. I can give the public IPv4 address, or I can give that public IPv4 DNS name. I'm going to give the IP address here, and port, it is 3306. username, it's wp underscore user, the database user. Okay, and everything looks good. Let me go ahead and test endpoint connection before creating the endpoint. So now it is testing. It's going to see if we can access the database from our replication instance. This will not take much time. It will be relatively quick. Just gonna wait here. Once the status changes to successful, and we will create the endpoint. Yep, now the status is changed to successful, so we can go ahead and create the endpoint. I'm not going to change the password and create another endpoint. That's the target endpoint, and this is the RDSDB instance. That's the Aurora RDSDB instance that we have created. And select RDSDB instance, and so DB instance 1, database 1, DB instance 1. Let's go to Aurora. Yep, database 1, instance 1. So I don't want to do select the reader instance. I'm going to select that, the writer instance. Go back here. I'm going to select database in instance 1 and provide access information manually. The server name is already has been populated here for us, and the port, it's 3306. Username is admin, and let's provide the password. And let's go and test the connection here. Run test to make sure that we are able to access the database before we create the endpoint. So like the previous one, it's not going to take much time. Currently it is in testing state. Once this completed, we'll go ahead and create the endpoint. Once that is done, it's easy. Like we need to create the replication task and complete the migration. On. So yeah, status is changed from testing to successful. That's good. Let's go ahead and create the endpoint. I'm not going to save the password for this as well. And now let's go ahead and create the task, database migration task. And I'm going to create database migration task. Task identifier. I'm going to name it as On-Prem to AWS PC task, and replication instance, the one that we have created earlier, and the source database endpoint, and the target database endpoint. I forgot to name it. It's a target endpoint. So this is the one that is created. And so we are not going to just migrate. We are going to migrate and replicate, because we have enabled the CDC. And so I'm going to do nothing here and stop task after full load completes. I'm not going to stop. I'm going to let the CDC run in the background. I will stop that manually. Validation with the data migration. Yeah, let's do that. And I don't need anything else here. Advanced task settings. Okay, I think that's good. We don't need anything. Table mappings. So it's gonna be wizard and selection rules. Let's add a selection rule and a schema. Let's enter a schema. Source name. It's WP. That's the WordPress database that I created in MySQL. And so I'm gonna leave everything else the same. I don't need this one. I'm gonna disable that pre-migration assessment and migration task startup configuration. It's gonna automatically start, and everything else good. Let's go back one more time and make sure everything is good. Migrate and replicate, that's good. Okay, how long do you want the continue replication from source to the target? I'm just gonna save for a limited time. So, but anyway, I'll go ahead and stop it manually later. I'm gonna run it for some time. Okay, yeah, I missed this field. You can leave it indefinitely also, but that's not the point. Like then we will end up having two databases. So eventually we want to migrate the MySQL database to Aurora RDS in AWS and then get rid of the MySQL database that is running on the database instance. And else. Okay, that looks good, and this looks good. Okay, I think we can go ahead and create a database migration task. Yep. So once this is created, so I'm gonna pause the video and come back once this is created, and we can I'll show you how the migration that is. It will start immediately and it will be progressing. I'm gonna pause it and come back. Database migration task is created, and you can see the status is in created, and I'm gonna select this one and migration progress. It's going on. So task status is starting, and the progress is currently it's 0, and at table statistics, if you go, like, it will show the migration. So I'm gonna wait for some time for that progress. Now the status is changed to running. Task status, it is running, and let's keep refreshing. It's a relatively small database, it shouldn't take much time. So I'm just going to toggle between the tabs. So here table statistics, so you can see that, like, that the repeats migrating, it's going on. Migration progress, it's just still 0, it's going on, it's running. I'm gonna pause the video and come back once the migration is completed. Database migration is completed. It didn't take much time. So now you can see the task status is load complete and replication ongoing. So this will be this state, like, until we go and manually stop the CDC migration. And the migration progress, if you see, it's 100% completed. And table statistics, everything is done and everything looks good. So we have created a new managed database, that is Aurora database, Aurora RDS database, and created an AWS database migration service replication instance that allows you to replicate data between databases. And we have created a source and target DMS endpoints, and we have modified the configuration of the source database to allow for continuous replication of data, that's binary log, and we have started the replication of data through DMS replication task. So we have completed our database migration from our on-prem instance, DB instance, to Aurora RDS DB instance. Next, let's go ahead and migrate our application, that's our web server WordPress application, from our on-prem instance to the AWS Cloud. Okay, I'm back in AWS Management Console Home. To get started working with the AWS Application Migration Service, the service must first be initialized in the AWS account. The initialization involves creation of IAM service linked roles and the replication server template. Replication servers are lightweight Amazon EC2 instances that are used to replicate data between your source servers and AWS, and their configuration is based on that template. So I have already used the AWS application migration service, so it is available in recently visited section. If not, you can go ahead and search for that one. So let me open that in the new tab. And since I have already used the service, that service is already initialized, let me go ahead to the replication template and edit, and we need to select the AWS VPC subnet public 1, where we are going to launch the instance, and everything else looks good. Replication server template type, instance type T3 small, and everything looks okay to me. And I'm going to save the template. And for the post launch template section, I have enabled SSM agent installation, nothing else. I'm not doing any post launch template configuration. And we need to install the agent now. So to install the agent, in order to deploy my application migration service agent into our source server, we need AWS identity and access management credential with the proper permissions. I have already created user, that's AWS MGN user, and you can see the policy name. I included AWS application migration agent policy, that's AWS managed policy, and I have also added an inline policy, that's a migration policy with these permissions. I will add these permissions in the description section. So I have the security credentials created, I can use that. So let me go to instances and let me connect to the on-prem web server. Connect using EC2 instance connect. I'm connecting to on-prem web server. Okay. Fine. Let me get the AWS application migration service agent installation script, and let's install it. Okay, let me give region as AWS East 1. And I'll give the access key for the security credential for the user that we have created, migration user, and the secret access key. To replicate all the disks, I'm going to press enter. So now it is downloading the AWS replication agent onto the source server. It's going to take some time, and I'm going to pause the video and come back once the installation is completed. The AWS replication agent was successfully installed. It took some time and it is completed. Now let's go to our application migration service console. And let's go to source servers and see it's already started, and we can see our source server name 172.31.19.52. That is 172.31.19.52. That is our on-prem web server as a private IPv4 address, and so it's initializing. We can see that we can go to the different tabs and see it's starting the data transfer, and it's in the initializing state. So this is the life cycle that we have seen. So one is that not ready, and then when it is ready, we can do that ready for testing and test in progress, ready for cutover in progress, and then cutover complete. So replication progress, it's happening. It's gonna take 19 minutes. It says like it's in progress and 7% is completed. It's agent based installation, and so already took 5 minutes, and so it's progressing. And if you go into the server tab, and you can see the details about the host name and what it is going to do, the hardware and CPU, the disks that it's going to migrate, and the tags. That looks good. And disk settings. So this is the disk. So we selected opted for to migrate all the disks, but we have only one disk in this source web server. And if you go to replication settings, so the subnet and the replication server instance type, so all these details you can review that here. And the launch settings, we can see that. And then we need to do some modifications here, and then we need to do post launch settings if we want to do some configuration. But for this demo, we are not going to do any post launch settings or configuration. Let's go back to dashboard, and I'm gonna wait for the replication. This is to complete. So 5 more minutes left. I'm gonna pause the video and come back once this is completed. Okay, that initial sync is complete to 100%. So let me go to launch settings, and under the general launch settings, click on edit and click on instance type right sizing. I'm just going to turn it off. Instance type is defined, whatever is defined EC2 launch template is ignored. So I'm going to do this one for the demo purpose. Click on save settings and I click on to the EC2 launch template. I'll click on modify. I'm going to modify that one. So I'm going to leave this here. I'm going to come down to instance type. I'm going to do T2 small. That's good enough. And maybe I'll use I don't want to use this one here. I'll leave this, or maybe I'll select keep. Fine. Network settings. I'm going to create a new security group, and I'm going to call it as AWS Web Server Security Group. And select the VPC or AWS VPC, and I'm going to add security group rule. I'm going to select this one as HTTP. I'm going to select anywhere and add another security group rule, maybe for SSH. I'll do that, and I'm going to do that anywhere. In real and world environment, we don't want to do that. We want to restrict that the particular IP address. I just want to do it for the demo here. This looks good. And under advanced network configuration, I need to select auto assign public IP. I need to enable this one. That's good. And storage looks good. Resource name, I'm going to name that as web server. That looks good. I'm not going to do any post launch configuration, so I don't have to give anything here. Let's go back from the top and then make sure everything looks okay. Okay, this looks good. Okay, everything looks good. Let me go ahead and create template version, and then view launch template. The latest version is this one. So go to action. Okay, select this one. Okay. Go to actions and set default version. Select 3 and set it as a default version. Okay, this looks good now. And okay, we are now back in application migration service console. And if you see the migration dashboard, and in the life cycle, it's moved to the ready for testing state, and initial replication is completed for the replication progress status. If you see that, so now we are ready for testing. You can go to test and cutover and click on launch test instance and click on launch. So it's going to launch test instance. Now the test in progress. If we can go back to console home and click on EC2 and open it a new tab and make sure we are in US East 1, that Northern Virginia region. And if you go to instances, and we have one instance now, that is AWS Application Migration Service Replication Server. And if you refresh, we should have another instance that will be created shortly here. That will be our test instance. Go back to here. Yep, the application migration service window. If you see that it's the test in progress, and if you see that job ID, and we can see that started taking a snapshot, and it's just progressing, and the status is started. It's ongoing. The status is pending. We can click on the server again, and yeah, you can see it's still in progress. And we'll go back and see if the EC2 instance is getting, yeah, now you can see that our if you can see AWS application migration service conversion server, that is getting initialized. Okay, it's yeah, we'll wait for some time. Once this instance is launched, I'll come back. I'll pause the video and come back. Okay, I'm back now, and let's check the job ID and the status. And this one has failed. Launching of a test or cutover instance has failed. The reason is an error occurred, invalid parameter when calling the run instance operations. Security group and subnet belong to two different networks. If you see the subnet, that's in 1722. Let's go back and see. That's a good pointer for us, like to debug and fix the issue. So let's go to VPCs and go to subnets, and the subnet that ends with the 1722. This is from our default VPC, not from our AWS VPC that we have created. So we have missed selecting the subnet in launch template. Let's go ahead and fix that one. Yeah, so this one, that's fine. Let's go back to click on the server and go to launch settings and select the EC2 launch template. Let's modify that one. And so now we need to modify this one here. Okay, yeah, subnet, we didn't select this one. We need to select public one, AWS VPC public one subnet. Okay, I think that's good. And everything else is good. Instance type and yeah, and the security group that we have created, that looks good. Advanced network configuration, auto assign public IP enabled, that's good. And yeah, everything else looks good. And create a template version, and let's go here and select this one and set this one as the default version. So mark that as the 5 as the default version. Okay, that's good. Now let's go to here and click on this one. Let's revert to ready for testing. Okay, this action cannot be bound to the server because it's being tested. Yeah, let's go ahead and so now we can go ahead and launch a test instance. We can launch this for one server. Let's launch this one. Okay, so now this is in progress. So we can check the progress here by clicking the job ID. It's going on. And if you go to the EC2 instance, this one, let's go to select a new tab for EC2 instance. Okay, and if you go on to the instances, we can watch the progress here, and we can go back and check the job details as well here. This is in progress. Next action is a complete testing and mark as ready for cutover. So this is in progress. I'm gonna watch the progress. So the conversion is started. Yeah. So I'll watch this one, and then I'm gonna pause the video and come back once the test instance is created. Okay. Test or cutover EC2 instance has been successfully launched. You can check the events here, and it is successfully launched. And if you go back to the servers and migration dashboard, and it says the next action is a complete testing and mark as ready for cutover. If you go to the EC2 console and yours is one region, our web server has been launched. And let's copy our public IPv4 address for the web server, that is the test instance, and let's see if we can establish a connection. It should fail. It should say like error establishing a database connection message, because we haven't configured our Aurora RDS database with a new web server. So that's fine. So once we get that error message, and that shows that like it's good, and we can go ahead and mark it for cutover, and then we can create the actual migration. I'm just gonna wait here for a minute. It shouldn't take long. It's still trying to establish a connection. Yep, it says error establishing a database connection. That's perfectly fine. Let's go ahead and close this one. And this one is from our on-prem web server. If you see the IP address, it's not the one from the one that is migrated to the EOS East 1 region. Okay, so that's good. And so this is fine. Let me go back here and go to test and cutover. We are in application migration service console, and click on test and cutover, and let's mark it as ready for cutover. Yep. Now, would you like to terminate the instance testing? Yes, we would like to terminate the instance that is launched for the testing, and we want to create the new one. Okay. So now it's ready for cutover. Okay, now if you go here, and yeah, now it's ready for cutover. It's now it says like a launch cutover instance. You can click on test and cutover, and launch cutover instance. Okay, yeah, now it's getting created. So starting to launch cutover instance. We can check the job ID for the cutover job. So we can check the events. So it will take time. So like last time, I'm gonna watch the events, and I'm gonna pause the video and come back once the cutover instance has been created. Okay, the Cutover EC2 instance has been successfully created, and you can check the event here. And so like we can go back to by clicking the server name, and it says like if launched status is now next status is like a finalize the cutover. Now after the launching the cutover instance, the AWS application migration service has created the final EC2 instance in the target environment. This instance was created based on the data from our source server, which means that our workload is still configured to the source environment. That means that it's configured to the database on the DB instance from the on-prem server. Now it is time to update the application configuration to use the database from our target environment, that is Aurora RDS DB instance. So to do that, let's now go to EC2 here, and we have our web server. This is the new web server at our instance, and the public IP for address, it's new one, you can see that. And I see this is this one, and let's now connect using EC2 instance connect. It's getting connected, establishing connection, it's getting connected. Once it is connected, let's go ahead and modify the WordPress application with updated database information for our DB user and DB password and DB host. So now let's do this, and where HTML WordPress, sorry, let me type it, HTML WordPress. Yep. Now let's update the config, wp config.php. Let's go and update that DB user password and DB host. And DB user, if you remember, for our Aurora RDS DB, we have used admin user, not the WP underscore user. That's the username that we have used for our on-prem server. Admin, and that's the same password that I used, super secure. And database host name, this is the IP address, private IP address for our on-prem DB instance that we need to remove it and then give our Aurora RDS DB identifier. Let's go to Aurora. Yep. And endpoint name, and I'm not gonna give that read only. This is the read only endpoint, so I'm gonna give this one. I'm gonna copy this one, and yeah, this is the one. Let's paste this one. I think this looks good. Database username, password, and the database host. Good. That looks fine with the correct values. Now everything is good. Now we need to change the inbound rule for our database inbound rule. Let's go ahead. EC2 security groups, and let's select our RDS DB security group and check the inbound rules. Click on edit inbound rules. Currently it is only allowing MySQL Aurora that access from port 3306 from our replication instance security group. But we need to edit this one here, add a rule, and again select MySQL Aurora. It's going to be custom again, but we need you select our web server security group. Okay, AWS web server security group. Okay, yeah, from this one we need to have access to port 3306. Save the rules. Now it looks good. Let's go to the instances again. Select our web server instance. Copy the IPv4 address, public IPv4 address from the browser. It should work. Yep, it works. Welcome to awesome AWS Community Builders site and my intro. And it is our application migration with AWS hands-on learning. Yep, works perfectly fine. Yep. Now we have to go out and finalize the cutover. Let's go to or not this one. Okay, application migration service, and click on test and cutover, and click on finalize cutover. Yep, cutover finalized. Good, everything good. So now once we are done, like if you don't want to see this one on this console here, we can mark as archived, but we can do that later. I'm not going to do that here. We have initialized and configured AWS Application Migration Service and deployed AWS Application Migration Service agent to the source application server, and we have customized the EC2 launch template to fine-tune how the rehosted server would be configured in the target AWS environment. And we have launched the test instance with the AWS Application Migration Service to validate the rehost process was functional, and then we have launched the cutover instance and reconfigured the application to the new target environment, and we have finalized the cutover process and executed housekeeping on AWS Application Migration Service inventory. So we have implemented the architecture that we have outlined during our presentation. We had our WordPress application and our MySQL database instance configured on our simulated on-prem server environment, that is on US West 2 region, and we have migrated the database using AWS Database Migration Service, and we have migrated to US East 1 region. We have migrated from MySQL to Aurora RDS database instance, and we have used the AWS Application Migration Service to migrate the WordPress application from our on-prem server, that is US West 2 to US East 1, and we have configured the newly migrated application, WordPress application, the web server on US West 1 region to use the newly migrated Aurora DB, Aurora RDS DB, and we have now successfully, we are able to access our application now. Hope you found this video useful. Please like this video and comment and subscribe to my channel for more AWS related contents. Thank you. I'll see you on the next one. Bye.